I suppose this master cylinder is just like any other, but would you review how it works?
Sure thing, Joe. But I want to warn you, it isn't exactly like or interchangeable with any of our other master cylinders. All tandem master cylinders have two separate brake fluid reservoirs arranged one behind the other. However, a single cylinder bore is used, and the two separate pistons operate in tandem. It's a lot easier to keep things straight if we call the rearward piston the primary piston, because it is actuated directly by the brake pedal. Besides, the primary piston supplies pressure to the front brakes, where more of the braking is done. The piston at the forward end of the master cylinder is the secondary piston. In normal operation, hydraulic pressure from the primary piston operates the secondary piston. The secondary piston supplies pressure to the rear brakes. Here's how those pistons work. When the brakes are applied, the weaker secondary piston spring is compressed slightly by the stiffer primary piston spring. The secondary piston is pushed forward, and the secondary compensating port is closed off. Pressure starts to build up in the forward chamber. At the same time, the primary compensating port has also been closed off. The right amount of fluid is trapped in front of each piston, and pressure is developed in both the primary and the secondary chambers.
You still haven't told me what's different about the master cylinder for these brakes.
The master cylinder for the single piston disc brake has a longer stroke and greater capacity than most of our other master cylinders. What's more, the division of capacity between primary and secondary systems provides more fluid reserve for the front disc brakes. Now, here's the rub. The master cylinder for Coronet or Belvedere equipped with a Hemi engine and disc brakes looks exactly like the master cylinder used with single piston disc brakes. But they must not be interchanged. As a matter of fact, neither the pistons nor the assembly should be interchanged. So don't mix up the hardware.
Thanks, Tech. And while we're on the subject of master cylinders, here's a tip worth remembering. If you ever run into a case of brakes dragging because the master cylinder won't compensate, don't forget to check the stoplight switch. If it isn't properly adjusted, it will keep the pedal from returning far enough to open the compensating ports.
I'll remember that. Now, is there anything else different about the hydraulic system for these brakes?
There are a couple of differences, so let's review the rest of the system.
As you probably know, the residual valve for the rear brakes is located in the forward or secondary outlet of the master cylinder. No residual valve is used in the primary or disc brake outlet.
Why do we need a residual valve?
The residual valve maintains a light pressure in the rear brake cylinders. This keeps air from being sucked past wheel cylinder piston cups when the brakes are suddenly released. Residual pressure expands piston cups tight against the cylinder wall. A residual valve must not be installed in the primary outlet. Since disc brakes have large pistons and no shoe return springs, residual pressure in the primary lines would make the disc brake shoes drag and wear out prematurely. And now let's look at this warning light switch. The brake warning light serves a dual purpose. In addition to warning the driver if pressure is lost in either the primary or secondary hydraulic system, it warns him if the parking brake is on as soon as the engine is started. The primary brake line from the master cylinder is connected to one end of the switch, and a line for the front disc brakes is connected at the same end. With the single piston disc brakes, one outlet at this end of the switch is plugged, and you'll see why a bit later. The secondary master cylinder line is connected at the other end, as well as a line leading to the rear drum brakes. At this end of the switch, one outlet is plugged on all applications. Now, inside the switch, a barbell-shaped double-headed piston with an O-ring in each end separates the front brake hydraulic system from the rear brake system. Two small coil springs keep the piston centered as long as the pressure is the same in both systems.
If pressure is lost in one system, for example the front brakes, pressure in the rear brake system pushes the piston off center. As soon as the piston moves far enough to touch the ground contact, the warning light comes on. The springs in the switch are quite stiff, so minor variations in pressure won't turn the light on. For example, residual pressure in the secondary system will not cause the light to come on even when primary system pressure is released. Although drum brakes have different characteristics than disc brakes, The single-piston disc brakes are designed to give excellent balance with the new rear drum brakes. However, on icy or slippery roads, it is desirable to reduce front-wheel braking. That's where the metering valve comes in. It cuts off pressure to the front brakes in the range from about 10 psi to about 115 psi.
Just how does that valve work?
With this brake setup, there's only one brake line from the warning light switch to the metering valve. That's why the other front brake outlet in the warning light switch is plugged. There are two lines leading from the metering valve, one to each front brake. Inside the metering valve, there is a check valve and a valve seat. The valve seat is mounted in a valve plate. A spring holds the valve plate closed. The check valve in the upper end of the push rod is normally opened to ensure complete release of the disc brakes. As soon as the brakes are applied, pressure pushes on the diaphragm at the lower end of the push rod. It only takes about 10 psi to move the diaphragm and push rod far enough to seat the check valve. Closing the check valve cuts off pressure to the front brakes. This provides good braking and steering control under slippery operating conditions because it reduces the likelihood of front wheel skid. When master cylinder pressure gets up to about 115 psi, the push on the check valve and valve plate overcomes the valve spring and unseats the valve plate. From about 115 to 500 psi, the pressure difference between the primary and secondary is gradually reduced until pressure to front and rear brakes is the same.
What's the difference between a metering valve and a proportioning valve?
A proportioning valve reduces pressure to the rear brakes to delay rear wheel skid on hard braking. The metering valve holds off pressure to the front brakes under light braking conditions. It's sometimes called a hold-off valve. To quick check the metering valve, apply the brakes gently. A very slight bump will be felt at about 1 inch of pedal travel. This signals the opening of the valve plate, admitting flow to the front brakes. If you have a helper, watch the end of the metering valve push rod as the brakes are applied. The rod should move out of the valve slightly as the brakes are applied and move back into the valve as the brakes are released.
And here's something else to remember. The metering valve affects the procedure for pressure bleeding the front brakes. Since the pressure bleeder is usually operated at about 30 psi, the metering valve will close and the front brakes won't bleed. If you use a pressure bleed tank, hold the metering valve push rod up while bleeding. Do not force the push rod beyond its normal open position, and never use a block or a clamp to hold the valve open. Here's why. If you block the valve open and apply the brakes, the block will keep the diaphragm extended. As a result, full pressure will rupture the diaphragm. If that happens, the valve will be ruined and you'll lose the fluid for the front brakes.
I'll remember that. Now tell me, is this one of the rear brake drums used with the single piston discs?
Yes, Joe, it's one of the new finned and flared 11-inch drums.
You'll be glad to know that this year we have a new parking brake cable assembly. It has stiffer return springs and cable lubrication has been improved. This new cable ensures parking brake release and reduces the possibility of rear brake drag. It can be used on previous models, providing you always replace both rear cables. One last warning before we sign off. With these new disc brakes, never use a 15JK wheel. You must use either a 15JJ wheel or a 15K wheel. And now, I want to thank Tom for telling us about the new single-piston disc brake system, and thank Joe and you fellas out there for being such good listeners. Before any of you tackle one of these new brakes, get out your service manuals. And don't forget to use the extra information in this month's reference book.